Alright, so today I want to go over section 10.4. It's a continuation of 10.3, calculus in polar coordinates. So basically, since we learned about polar coordinates and polar graphs in 10.3, now we're going to see how we can apply calculus to polar coordinates. So we're going to go over area in polar coordinates. We're going to go about we're going to talk about arc lengths, tangent line, to equations of polar coordinates. First, let's discuss areas in polar coordinates. Areas under a curve or areas between two curves. So if r equals f of theta, so that's a polar equation, is a non-negative continuous function over a closed interval AB, then the area bounded by its graph and the base theta equals A and theta equals B. So basically we have theta equals A and then say theta equals B, and we want, that's the graph r equals f of theta, so we want this area is given by area is integral from A to B 1/2 f of theta squared d theta, or we can write it as 1/2 integral A to B r squared d theta, because r is f of theta. Okay, and b minus a is between 0 and 2 pi. Okay, b minus a is between 0 and 2 pi. So here's an example. Find the area of the region by the spiral r equals theta, where theta is greater or equal to 0, between theta equals 0 and theta equals 7 pi over 4. So again, area is 1/2 integral from 0 to 7 pi over 4 r squared, which is theta squared d theta. So it's 1/2 theta cube over 3 between 0 and 7 pi over 4. So that's theta cube over 6 between 0 and 7 pi over 4, which would be 7 pi over 4 cube over 6 minus 0, which is 343 pi cube over 384 square units. It's an area. Okay. Alright. That's straightforward. Example 2. We didn't even need to graph it. Sometimes it helps to graph. Find the area, and you have your grapher to do that, of the region common to the interiors of the cardioid r equals 2 minus 2 cosine theta, and the limacon r equals 2 plus cosine theta. So if I draw the graphs, the limacon, the cardioid, 2 minus 2 cosine theta, so at theta equals 0, r is 0. At theta equals pi over 2, r is 2. So 2, it's going to be negative 2. If you go to 3 pi over 2, and it's going to be negative 4. It's going to be 4 over here. So you will have a cardioid that stretches along the negative x-axis because you have a negative cosine. We learned from 10.3. This is 2, this is negative 2, this is r was 2 minus 2 cosine theta. And then the limit on, since a is greater than b, 2 is greater than 1, it's not gonna touch the origin, and it's not gonna have a loop. And it's 2 plus cosine, so it's gonna stretch along the cosine, the positive x-axis. You can check as theta equals 0, that's cosine 0 is 1, 1 plus 2 is 3. And at theta equal pi over 2, it's 2, so it's gonna cross here also. And at pi, it's negative 1, so it's gonna be 1. So basically, it's gonna look like this. Again, you have a grapher, you can check it. So we want the area of the region common to the interiors of these two graphs. So what I'm gonna do, I'm gonna take this piece that I'm circling in red, which equals this, and I times it by 2. Okay, so let's start at 1 first. So the area is, that's theta equals 0, theta equals pi over 2, 0 to pi over 2, 1/2 r square, which is 2 minus 2 cosine theta squared d theta. So this is from 0 to pi over 2, and that's the same area, so we times it by 2. This is area 1 plus the second area, which is going to use green for that. It's from pi over 2. So, oh, green. This is not green. Okay. We take this part right here. It's from theta equal pi over 2 to theta equals pi over 2 to pi, and that's the lemma cone. We times it by 2 to get this part as well. So plus twice integral pi over 2 to pi of 1/2 2 plus cosine theta squared d theta. Okay, so that's A2. So I'm going to do them separately, although on the notes I did them all at once, but I want to explain them more carefully here. So A1 I'll rewrite that 2 integral 0 to pi over 2 1/2 2 minus 2 cosine theta square d theta, and then we'll worry about A2 in a second. So if we FOIL this, well, 2 times 1/2, it's going to cancel out. Okay, if we FOIL this, it's going to be 4 minus 8 cosine theta plus 4 cosine square theta d theta, which we can factor the 4 out to make it easier. That's integral 0 to pi over 2, and it will be 1 minus 2 cosine theta plus cosine square theta. Well, this can be integrated easily. This can be integrated easily. This has to be to 1/2 plus 1/2 cosine theta to theta, the half angle formula. So if we do that, it's going to be 1 plus 1/2 is 3 over 2, and then minus 2 cosine theta plus 1/2 cosine 2 theta. Integral 0 to pi over 2, there's 4, is d theta. So it'd be 4. Integral of 3 over 2 d theta is 3 over 2 theta. This is negative 2 sine theta. And this is 1/2 times 1/2 is 1 over 4 sine 2 theta. that's from 0 to pi over 2. So if we plug pi over 2 there, it would be 4. 3 pi over 2 minus 2 times sine over 2 is 2 times 1. And sine 2 times pi over 2 sine pi is 0. And then minus 4. If we put in a 0, we get 0 minus 0 plus 0. So this would be 4 times, that's 12 pi over 2, which is 6 pi minus 8. That's A1. Now let's go to A2, the second integral, which is the which is 2 the integral of pi over 2 to pi of 1/2 2 plus cosine theta squared d theta. Again, these cancel out, so you have 4 plus 4 cosine theta plus cosine squared theta. Again, this is 1/2 plus 1/2 cosine 2 theta. So 4.5 is 9 over 2. 9 over 2, and then plus 4 cosine theta plus 1/2 cosine 2 theta d theta from pi over 2 to pi. So it's 9 over 2 theta plus 4 sine theta plus 1 over sine 2 theta from pi over 2 to pi. And that's going to be 9 pi over 2 plus 4 sine pi, which is 0, and then sine 2 pi is also 0, minus, if we plug the pi over 2, it's 9 pi over 4 plus 4 plus 0. So the pi, that cancels out, so it's just it's just minus 4. So it's 9 pi over 2 minus 9 pi over 4, which is 9 pi over 4 minus 4. So A equals A1 plus A2, 6 pi minus 8 plus 9 pi over 4 minus 4, which would be which would be 24 plus 9, 33 pi over 4 minus 12. Well, I might have made a mistake somewhere because in my notes I have 21 pi over 4. So let's see. Let's check that. Minus 2, let's check the math. So it would be, if you put pi over 2 there, oh, I see. That would be, if you put pi over 2, that's 3 pi over 4, my bad. And then that's minus 2, and that's 0, and then minus 4, 0, 0, 0. So this should be 3 pi over 4, which would be 3 pi minus 8. Okay, so please fix that. 3 pi minus 8. So 3 pi minus 8, that would be 21 pi over 4 minus 12. Alright, so that was just 3 pi over 4 times 4. Alright, so what about if we have the area between two curves? Area bounded by two curves. So if you have equals f of theta, and r equals g of theta. So these are two curves between theta equals a and theta equals b. So we want this area between the two curves. Okay, so if f and g are continuous and f of theta is greater or equal to g of theta, it's the above curve over AB, the area bounded by r equals f of theta, r equals g of theta, and theta is a and theta equals b is just like rectangular. It's 1/2 integral from a to b f theta squared d theta minus 1/2 to the g of theta squared d theta, which we can write as 1/2 integral a to b f of theta squared minus g of theta squared d theta. And here's an example. Find the area of the region in the first quadrant that is outside the circle r equals 1, and inside the rows r equals 2 sine 2 theta. So we only care about the first quadrant in this case. In the first quadrant, r equal 1 is a circle center at the pole, radius 1. So it's something like this. That's r equals 1. And that's a rows. It's going to have twice, because this is even, it's going to have twice as much petals. So it should be there should be 1 at pi over 4, because sine 2 theta equals 1. That means, remember how we did that? That means sine 2 theta equals sine pi over 2. Means 2 theta is pi over 2. Theta is pi over 4. So at pi over 4, so you're going to have at pi over 4, you're going to have r equals 2. So you're going to have somewhat like this. 2 units. 1, 2. Anyway, you put it in your calculator to the graph. So you want the area in the first quadrant outside the circle and inside the rows. Okay, outside the circle and inside the rows. Okay, so where do these cross? What are these points? We set them each other. So 1 equals 2 sine 2 theta. Sine 2 theta equals 1. That means sine 2 theta equals 1/2. So 2 theta equals either pi over 6 or 5 pi over 6, right? Or 7 pi over 6 or 11 pi over 6. Well, that means theta equals pi over 12. 10 pi over 6. What's 10 pi over 6? 5 pi over 12. And then 7 pi over 12. And then 11 pi over 12. But we only are looking for the first quadrant. As obvious, there's only 2 of them. This is going to be more than pi over 2. So that's going to be more than pi over 2. So this is the value. So this is theta equal. This is theta equals pi over 12. And this is theta equals 5 pi over 12. So we can get the integral. So the area is 1/2 integral pi over 12 to 5 pi over 12. The higher minus the lower, the outer minus the inner. So the outer square is 2 sine 2 theta square minus the circle, which is the inner, d theta. So area equals 1/2 integral pi over 12 to 5 pi over 12 for sine squared 2 theta minus 1 d theta. using the double angle formula, the half angle formula, this would be 1/2 over 12 to 5 pi over 12 of 4, and then that's going to be 1 minus cosine 4 theta over 2 minus 1 d theta. So it's 1/2 integral pi over 12 to 5 pi over 12, 4 times 1/2, 4 times, so this would be 1/2 minus cosine 4 theta over 2. 4 times 1/2 is 2, 2 minus 1 is 1, and then minus 4 times cosine over 2 is 2 cosine 4 theta d theta, so it's 1/2. Integral of 1 d theta is theta, that's 2 over 4 or 1/2 sine 4 theta pi over 12 to 5 pi over 12. So if you plug that in, it's going to be 5 pi over 12 minus 1/2 sine 5 pi over 3, right? 4 times 5 pi over 12 is 5 pi over 3 minus 1/2. If we plug pi over 12 in there, it's 1/2. 4 pi over 12 is pi over 3. And you end up with pi over 6 plus root 3 over 4, which is roughly 0.96 square units. Alright, so finally we're going to talk about arc length of a polar curve. Arc length of a polar curve. So remember, going from polar to rectangular, theta r y x, we know that x equals r cosine theta and y equals r sine theta. If r is f of theta, then x equals f of theta cosine theta, y equals f of theta sine theta. And these are the parametric equations. If theta is the parameter, they are the parametric equations for the polar curve. R equals f of theta, as long as theta is considered a parameter. So now if you want to find dx, so given this, you want to find dx by d theta, you will see why in a second. Using the product rule, it's f prime of theta cosine theta plus, so I did derivative of this times second, and then derivative of the second, derivative of cosine is negative sine times f of theta. And if I do dy by d theta, again product rule, f prime of theta sine theta plus derivative of sine is cosine, so f of theta cosine theta. So now if I do dx by d theta square plus dy by d, equals f prime of theta cosine theta minus f of theta sine theta square plus f prime of theta sine theta f of theta cosine theta square. You know, foiling that, and using the trig identity, sine square plus cosine square equals 1, you're going to end up with dr by d theta square plus r square. Remember, r is f of theta and dr by d theta is f prime of theta. Okay, dr by d theta is f prime of theta. So that's what you get for that. So now we can talk about the length of a polar curve. Length of a polar curve. Let f be a function for which its derivative f prime is continuous. So we're talking about smooth curve. It's continuous over AB. Then the length L, then the length L of the graph of r equals f of theta over AB. So that portion of the graph A and B is integral from A to B square root of dr over d theta square plus r squared d theta. And we got this because that's what we got in parametric. Now it's in polar when we saw that they equal each other. Okay, and here's an example of that. Find the length of the cardioid r equals 1 plus cosine theta, where theta is between 0 and pi. So we write down the formula. L equals 0 to pi square root of dr by d theta square plus r square d theta. So we have r right here. We're going to do dr by d theta, which is derivative of 1 is 0, derivative of cosine is sine. We're going to square it. Dr by d theta square equals sine square. We're going to this to r square. So dr by d theta square plus r square equals sine square plus r square, which is 1 plus cosine square. And that would be sine square. If we FOIL this, we get 1 plus 2 cosine theta plus cosine square. Two guys add up to 1. 1 plus 1 is 2, so 2 plus 2 cosine theta, which is 2 to 1 plus sine theta. And we wanna have a perfect square. We can, because 1 plus cosine theta is cosine square theta over 2. Okay, it's cosine square theta over 2. So L equals integral from 0 to pi of cosine square, it's 2 cosine square, 1 plus cosine, 1 plus cosine theta, it is 2, yeah, so we need another 2 here. So you get 4. When you square root it, you get 2. Square root of cosine square is cosine theta over 2 d theta. Alright, 1 plus cosine theta equals 2 cosine square theta over 2. Okay, that's the half angle formula. Alright, so this would be, we pull the 2 out, integral of cosine is sine times 2. So it's going to be sine theta over 2 from 0 to pi, which is 4. Sine pi over 2 is 1 minus 0, which is just 4. Okay. And I believe that's it for 10.4. So I covered just about every aspect of 10.4. I'll see you in 10.5.